Hi everybody, how we doing? It's been a little while since we've had a video, so I hope you're excited to hear some chapter 11 review. Of course you are. Okay, so we actually learned 4 different 4-step processes in chapter 11. We learned matched pairs interval and matched pairs test, and then we learned 2 independent sample interval and 2 independent samples test. Okay, so what I'm going to do is first start with the matched pairs. So and you have paired data. Okay, so let's talk for a minute about what paired data is. So you have, this is typically with an experiment, you have the subjects getting both treatments but randomly deciding the order. So subjects are getting both treatments but randomly deciding the order. They might have treatment 1 first and then treatment 2, or treatment 2 then treatment 1. And that would be where the randomness would come in, because they're all volunteers in an experiment, so you have to put randomness in somehow. And for the calculate portion, you subtract the data to get differences, and treat the differences as your one sample. And this will be mu d. So in this case we're talking about one sample and we're trying to find the mean difference. And then it looks a lot like chapter 10. So at this point you have one sample, so we're going to kind of go back to that. So we're going to compare and contrast the matched pairs interval and we're going to contrast that with the matched pairs hypothesis test. Okay. So what does their identify look like? So this one's an interval. Every interval starts the same. We wish to estimate mu d equals the mean difference of, and then your context would go here, at blank percent confidence. So remember, an interval has to have a confidence level given to you in the interval, otherwise you can't do the problem. And if it's not given to you, check my notes that I did previous review to see the difference between an interval and a test, because if it doesn't have a percent confidence, you're probably dealing with a hypothesis test. Okay. Identify for a test, you're going to have your null hypothesis and typically here, this is going to be 0. Sometimes there's a claim. So I am going to leave this equals because sometimes there will be a claim like the mean, someone claims the mean is, 5 or something, and this would be 5, but most of the time this is 0, and if you're not clear in the problem, put 0. Alternative hypothesis, you can have greater than, less than, or not equal to. You need to have an alpha level. Remember, it's 0.05. If it doesn't say, I know you guys know that. If anything, we know that. And then you state context, mu d equals the mean difference of link, and you got your context in there. Okay. Now, the conditions are the same for both of these. So what I'm going to do is I'm going to mark this off, and I'll show you why. So I want to actually spend a little bit of time on the conditions. I will not do the conditions twice though. So when I get to the 2 independent samples, don't worry, I'm not going to do this whole thing again. Okay. I want to spend a little bit of time on the conditions because we have been working on the difference between an observational study and an experiment, and you can tell why, because a lot of times this matched pair situation is going to be an experiment because you're randomly assigning treatments to subjects. Okay, so for our conditions, we're kind of on the hunt for 2 different things now. We want to tell if it's an observational study or an experiment. And your conditions will look a little bit different. Okay, now I want to be really careful. This is interval, this is test. This section for the conditions is completely separate, and it can go with the interval. Either one of these can go with the interval, or either one of these can go with the test. This is completely different. Observational study does not go with interval. An experiment does not go with test. Just because I have them lined up like this doesn't mean that. It means that your conditions are different for each problem. You need to check if you have an observational study, you follow this. If you have an experiment, you follow this. Most of the time, matched pairs is going to be experiments, but I want to just check everything. Okay. You guys are like, how do you know? Alright, well, the easiest way to tell is looking at the wording of the problem. So, okay. And in an observational study, it's going to say random selection, randomly selected, SRS, something like that, random sample. Okay. In an experiment, it's going to say random assignment. And I want you guys to think about that little tree, it's not a tree, little flow chart we made where we had the subjects and then they were randomly assigned to groups. So that is where the random assignment came in. You don't have a random sample because those are volunteers. So that's the difference. It's not ethical to randomly assign someone to a treatment. You have to have a volunteer first. These guys, you can take a sample and observe them. You're not really doing anything different. You're just watching. And asking them to do a survey is an observational study. Okay. Random, independent, large counts. Okay, so this will say randomly selected, random sample, random something, just like you're used to. And then this one will say random assignment. Okay, now for the independence condition, actually I'm going to put or assume. And this one is technically or assume also, because if you have an experiment, it might not say random assignment, but I have never seen that before. That would be like ridiculously challenging, and I don't suspect that I or College Board would do that to you, but okay. So n times 10 is less than or equal to all population, or assume. And this would be like in the problem it said, assume that this was an independent sample. For example, the trash ball, it said in the context of the problem, assume that this represents a random independent sample. This one, you get to say random assignment for both, because one of the beautiful things about random assignment is it assures that each one will be independent of each other. So you'll go this group and this group, and then you'll switch. So for matched pairs, if you remember, it switches. Okay, large counts condition, n is greater than or equal to 30, so CLT applies. Same here. Okay, Asad, what do you do if it's less than 30? Okay, if n is less than 30, and this is for both cases, do one, this is very important, one box plot for the differences. You're treating the differences as your sample, so you just want to do one box plot for the differences. Don't do a box plot for like treatment 1 and a box plot for treatment 2 and then a box plot for the differences. Just do one box plot for the differences because that's your sample, mu d. Okay, so that's it for conditions. Okay, calculate. Okay, so for the interval, formula packet. Please hold, everyone. My side is slightly unprepared. There we go. Okay. Alright, so the interval right here, statistic plus or minus critical value times standard error of statistic. Okay, so our statistic is the thing we're interested in, which is here, mu d. However, statistic means sample, so we have x bar d, so sample mean of the differences. A lot of times this will come from one variable stats. If they give you like a list and you have to subtract. Plus or minus, okay, critical value is t star, and standard error of statistic. Okay, so I want to mention we're here in the means section. We're doing one population because we're mu d. We are treating it as one sample. So your standard error is here. So you have S of xd. So this is the sample standard deviation of the differences. Again, a lot of times you'll get this from one variable stats. If they don't give it to you, over the square root of n. Okay, so this guy and this guy you might get from one variable stats if you're working with a big table. Sometimes they'll just give you summary statistics with that already calculated, but if you don't have it, this is where you need to get it from one variable stats. Okay, just a note for T star. T star equals inverse T 1 minus the confidence level over 2 comma degrees of freedom, and degrees of freedom is n minus 1. Okay, and you'll get your interval. Now for the test. Okay, actually let me just finish this out. Conclude. We are blank % confident that the interval from blank to blank captures the true mean difference of context. Okay. All right, now for hypothesis test, right here, standardized test statistic equals statistic minus parameter over standard error of statistic. Okay, so my statistic is still x bar of the difference minus the parameter, which is mu, and that is located here. Most of the time it's 0. Over standard error of statistic is the same one that's right here. Again, a lot of times this and this will be from one variable stats. Okay, so you're going to get your t from that, and then your p-value. Okay, so just a note, for negative t, it's going to be negative infinity to t degrees of freedom, and for a positive t, it's going to be t to positive infinity degrees of freedom. Okay. Okay, so since our p-value of blank, we reject the hoe, we fail to reject the hoe, depending on this. It appears that blank. And then basically at this point you copy the context of the problem. What was the question asking? Either your null or alternative hypothesis in words here. Okay, so that is a lovely, look at that, it's beautiful. It's a lovely summary of everything matched pairs. Okay. So now I'm going to turn the paper over and we're going to do the 2 independent samples. I am not going to do the conditions, however, this fully, so it's going to be a little bit smaller than this. Okay, so we have 2 sample and 2 okay, and this is 2 independent samples. So the subjects in group A or the people chosen in group A are different from the people chosen in group B. The goats chosen in group A are different from the goats in group B. They have separate subjects. Okay. All right. We wish to estimate mu1 minus mu2 the difference in means of group 1 of the goats eating the grass at Lake Herman and group 2 of the goats eating grass at Lake Herman at blank % confidence. Personal note, my family and I went to take a hike by Lake Herman and we saw the guy loading the goats into the trailer with the dogs, and it was the most interesting experience. Anyway, okay, so for the test, it's a little bit easier than mu-d, believe it or not, because this one is always the same. mu1 minus mu2 equals 0. Again, it's best to put letters here if you can to identify which is which. Some of you might worry about which one should I subtract. Again, it doesn't matter. What matters is that you line up this part properly. So greater than, less than, not equal to. This part's lined up properly. So what I like to do, you guys already know this, I like to take the context of the problem, go off to the side and say, okay, it's saying something about the goats in group A eating more than the goats in group B, and then what I'll do is subtract this over to get this order, and then I will put my null hypothesis in the same order. So I will do this first before doing the null hypothesis. Then I'll subtract that over to get this one in front and this one second, and then I'll make that the same for the null hypothesis. Okay, and then mu1 equals whatever context this is. The mean amount of grass the goats ate in group 1. The mean amount of grass that the goats ate in group 2. Okay, and then you've got your alpha level. So this has a little bit, I think this is easier. And just to go back to mu-d real quick, again, some of you guys might be thinking, but Miss I, you never said which way to subtract. It says subtract the data to get differences and treat the differences as your one sample. It doesn't matter. What matters is that you read the context and understand if that should be greater than, less than, or not equal to, depending on how you subtract it. For the interval, you're going to get the same exact interval, it's just the same numbers, but they'll be negatives versus positives. We've done this before. And for this, you'll just get the negative t versus the positive t. Since the curve is symmetric, it's not going to matter. It's okay. Okay, same dealio here. It's not going to matter. And you might see at the end, like it doesn't come out right. For example, like say, I'm sorry to switch back and forth, but here, let's say you have less than, and your t comes out positive. You might want to go back and take a look at this and make sure that it should be greater than, because if you have a positive t, you should be looking at the right side of the t curve. So it's probably greater than. This is a way you can check yourself. Again, it's not a deal breaker because you're going to get the same answer in the end anyway. Okay. Now, for the conditions, I don't want to say, don't want to do that whole thing again. But what I do want to say, and this is the annoying part about two independent samples, is you have to do sample 1 and sample 2, and you have to do them separately. So refer back to the matched pairs for that detailed description on what to do for the conditions. But as far as this goes, it's the same thing as the matched pairs. It's just that you have to do sample 1 and sample 2 separately, which we know is a pain. Okay, so here's where it gets interesting for the calculate portion. All right. So I'm here for a confidence interval. It says statistic plus or minus critical value times standard error of statistic. Okay, so the statistic, this is the parameter here. This is what I'm trying to estimate. So the statistic for that is x bar 1 minus x bar 2. I'm going to put that in parentheses because I want you guys to see that that's one number. That is your statistic. Plus or minus t star is your critical value. Okay, so now I want to show you, and you guys have been working with this, I hope. Here is the formula for two populations, so for two independent, here is your standard error formula. So you have the standard deviation 1 squared over n1 plus the standard deviation 2 over n2. And just for my math nerd people out there, this is squared on the top, which sort of cancels out the square root, and then those would be square rooted on the bottom to make it look like this. But since they're combined together, we make it this way. Okay, and then our conclude for this. We are blank % confident that the interval from blank to blank captures the true difference in means of your first thing and your second thing. Okay, not so bad. Okay, now the test will probably have a little bit more, oh goodness, I just made a line on the paper, calculations. Okay, so back here, standardized test statistic. statistic minus parameter over standard error of the statistic. Okay, so standardized test statistic is t. Statistic is the same thing as this, x bar 1 minus x bar 2 minus the parameter is 0, that's from here, over standard error of the statistic is the same as this. Okay, and then you need to get your p-value. Okay, same thing as the last one. So you guys know how to do this. It appears that, and then write either your null or alternative hypothesis in words, or copy it off of what the question was actually asking. And that is it for chapter 11. We'll talk to you guys soon.